Hello everyone, today we have something very interesting to take apart. Some time ago Dave from the AAV blog made a video about a Cypress AAD or automated activation device. Today we have another brand of AAD and it's called ARGUS. The device consists of an enclosure for the battery and for the electronics, a display with a button so we can turn it on and off, and a cutter that would deploy the reserve parachute. This type of AEDs are used in piggyback style parachute system. The rig has a section for the main parachute and another section for the reserve. The Argus in our case would be put in the reserve section. The AED would measure the altitude and the speed of descent of the skydiver. If he or she is below 300 meters and still in free fall, the device would activate. Here's some picture of such a container. We can imagine it like a jack-in-a-box. The flaps close on top of each other. Inside of the container there is the reserve and a parachute with a spring. If we slice the container, it would look something like this. This would be the body of the container with the flaps that go on top of each other. Inside we would have the parachute, the canopy of the reserve parachute. On top of it there would be a spring, and all of this would be held with a string. It's a special kind of a string like this one, like cypress wood material, and it looks like something like this. So this end would be attached to the bottom of the container. It would go through the reserve, through the spring, all of the flaps, and the loop would show on top. And there would be a pin inserted inside of the loop that will prevent everything of popping, of opening, the flaps of opening and the spring popping off. This cutter would be placed either on the bottom of one of the flaps or in the bottom of the container. The loop itself is passed through the cutter and it will be held like this. And again, if the skydiver is in free fall under 300 meters, this cutter will cut the string and the whole thing will open. The spring will push out the parachute and the parachute will take out the reserve canopy. The Argus actually has a bad reputation because a few years back a Polish skydiver died while having this AED installed in her parachute. The cutter failed to cut the spring, so the reserve never opened. Anyways, let's get into the electronic side of stuff. First thing we can see is that we have two connectors, again for the display and for the cutter. These ones are secured, so they are pretty hard to open or loose. We see that they have different count of pins, so there you cannot mess the connection up. Again, compared to the Cypress AD, this one is quite smaller, and also the body is aluminum. Another thing that makes difference is that this device has a compartment for batteries, and the batteries are changeable. So you can open this hatch here and put your batteries inside. This particular device uses two lithium CR123A batteries in series. You can see that they go inside like this and you close it. Again, this is way better than the Cypress in my opinion because you don't need to disassemble the whole thing to change the batteries. You can do it yourself, and also this thing, like without batteries, it has unlimited shelf life. Let's go to the other side. Again, we have these rubber seals here to prevent dirt from entering the device. I don't think that it's waterproof because neither the connectors are watertight nor this hatch, because you can see that this bolt goes inside of the inside of the seal, so water is coming from here anyway. I think this is just to protect from dirt, and also you can see that it has some kind of a paper filter inside to prevent dirt from entering from the pressure port here. Again, like the Cypress one, the moment we open it, we get some wires soldered in. Let me see if it has some. No, I think it's, yes, it's press fit. There is no screws holding the electronics to the chassis. It has two washers to prevent the contact from the batteries to short out. You can see that we put the batteries here and they are accessible from the other end. Again, this is quite a tight fit. Um, I don't like wires like this for a few reasons. One is that this is manual work, so it's prone to errors, the quality is not guaranteed, and also it takes more time, it's much more expensive than if these connections were soldered, if those connectors were soldered directly to the PCB. Also, let me see if we can show you, there is some damage on the components themselves from the aluminum body, from this one. That's not great stuff because especially when you skydive there is a vibration, so all of these things would be like vibrating and rattle inside of the case. Also, these springs are not meant to be soldered like this. Uh, this is not a standard way of using those. They should be soldered like this on a PCB flat. Here we can see that we have two PCBs. So this again, it's much more expensive to have two PCBs. The connectors themselves between the boards are more expensive. This means that a lot of assembly time goes into one of these devices. This is hand soldered, so yeah, this would make the device much more expensive. Again, I understand why they've done it this way, because much like the Cypress one, um, half of the space in the device would be just the batteries, so they are quite space limited. Um, to continue with this, I will unsolder these connections, those two things, those springs, and I'll get back to you. Let's have a quick look at the display. The cable has some ratings. It said shielded 26 gauge PVC, minus 25 plus 90 degrees Celsius, 4 amps at 50 volts. So we know the cable is good. This display had a plate, but the plate was glued with a very strong adhesive to the body, so I can't imagine it being serviceable. It was held by two screws that I already took out. Here we can see that display is directly soldered through the PCB. That's okay, I guess. On the back we have a micro that is Texas Instruments, but also it has a ARGUS laser etched on it as well, so something custom is going on here. These ports have Captain tape. I guess this is for the programming and debugging. On this solder mask it says RX, TX, 3.3 volts and ground, so I guess the display communicates with the main electronics with a serial connection. Also, we can see some Kapton tape inside for isolation. They didn't want to short anything else, and some sticky double-sided tape for uh, holding everything in place, I guess. Or yeah, not much to it, just a micro with a button and a display. So let's see the other thing as well. Here I unsoldered the battery connectors. Now we can take this apart. You can see on the top we have this is a Zener diode. It's a onsemi 744. This thing right here, it is a BTS 118D, which is a smart wall side power switch, and this one is BTS 462, which is a smart high side power switch. So I've put it with, I tested it with a multimeter, and it's connected to the both pin of the cutter. So these things actually connects both the high side and the low side. If we take it apart, on the back, uh, and this is Maxim part. It's Max 8880, which is an LDO with a power OK pin. So if something goes wrong with the power, the micro would know. Here are some discrete components. We have two filters and some transistors. Maybe they help switch those big guys on the back, and some caps for filtering. On this part we can see the microprocessor. It is Texas Instruments M430. Uh, this processor is actually the same one that the Cypress AAD uses, so they picked the same part for this device. And we already know from Dave's video that this is safety qualified part. Again, a connector for test and debug and or program. On the other side, this chip is Atmel H804, which I found to be an EEPROM. This is the sensor for the atmospheric pressure. You can remember they've had some problem identifying this part. This part is actually MS5534A, which is different from the TE MS5534C, which you can see and find data sheets. Actually, this part with this blob on the back is from a company called Intersema, which if you Google it, and open its website, it redirects you to TE. And my guess is that at some point TE bought Intersema. And if you go to the TE site, you can find that inside of this metal cylinder here, there are two silicon parts. And my guess is that the one silicon part we are missing is here on the back. And TE just took it from the backside and put it and coexist inside of this can here. But it's pin-to-pin compatible. The MS5534C that TE sells is absolutely the same, and the pins are absolutely the same as the MS5534A from Intersema. I already told you about the EEPROM. This one is a Texas Instrument part again, which is a op-amp, and this one here, those two, this component first, this is a magnetometer. But the interesting thing about this part is that it can be used to measure current as well. So my guess is all of these parts here are used for current measurement and for the battery of the device. With these parts they can see the charge state of the battery, and if there is not enough juice in the batteries, the device would not turn on at all. So yeah, this is the brains of the operation, and this is the PCB from the display. You can see again we have the same processor M430F69, which is again a Texas Instrument chip, and it's also branded with the ARGUS text. Here interesting device is this. It has a coil on the back, and it is high voltage EL lamp, so it supplies the current for the backlit of the display. And on this side we have the parallel connection for the display. The display is 128 by 64. The controller for the display is from Novatech. So yeah, those are the electronics, all of the electronics that are in the device. You can see that the component count is not that much. The processors are pretty expensive, but to be rated, they pay the big bucks. I actually have two AADs that I disassembled. Those are the insides of the two. This one, it has a sticker that says test OK, and this one doesn't have one. I don't know if it's supposed to be like this or it just skipped the quality phase, but yeah, this has a sticker. But also, if we zoom in, I don't know if we can see with this lens, but here it has a solder bridge on this chip, but it tested okay. On this one we don't have such a problem, but it doesn't have the sticker, so I don't know what's going on there in ARGUS land, but yeah, that was what I got from the two devices. Otherwise, there is absolutely no difference between the two. The chips are absolutely the micros are absolutely identical. All of the components are the same. Yes, but this is what I got when I expected the ports. So yeah, very interesting. So I've rigged the cutter so we can test it. I've put my power supply to the maximum current it can supply and put it in 6 volts, just like the two batteries, and we'll see what will happen. Okay, let me just connect the leads. As you can see, not very dramatic. Let's see if everything worked as advertised. The actual cutter gets really hot, like hot to the touch, and we have a perfect cut. Guys, here is a close-up of the cutter. You can see that it's not very dramatic as Dave's video showed. Here in the background I have all of the parts from the first cutter. You can see that I've removed the end cap, so the explosion wasn't contained and everything flew apart. I laid out all the parts of the cutter for you to see. Maybe it's interesting for you. Here is the body of the cutter. This is the piston that actually shoots out and cuts the thread. Here is the cup that holds the pyro charge, and this is the igniter and the end cap. When everything is properly assembled, of course, works like a charm. When you mess with it, it's get much more exciting. So guys, I hope you liked the video and it was interesting for you. I wish you all the best and see you in the next video.